Yes, so good morning, students. So we are continuing with our session on linked list, and we know that it is the second data structure that we are seeing. We know that the memory allocation in linked list is dynamic, and when we talk about linked list, we talk about node creation, and in node creation, basically we know that there are going to be two components. One is going to be the data, and because it is going to have a dynamic memory location, or we can say the elements of the linked list are not going to be arranged into a sequential fashion. uh, that's where what will happen is that it will also have another part into the node, which is basically known as the next part or the link part or the address part, which is going to store the memory location for the next node into your memory. Now, one more important point over there is there that because the linked list can expand dynamically, as in it is not necessary, it will never ever have a fixed size. So somewhere, wherever the linked list has stopped, so it might be possible that the linked list might have 5 nodes right now, and maybe after some time it can grow and it can have, let's say, 6 nodes or whatsoever it is. But in any of the case, we should know a terminating condition where actually the list has stopped right now. So whenever we want to traverse or whenever we want to go to the end of the list, it becomes easy for us. And that's why when we talk about the terminating condition of a linked list, so what is done is that whichever the last node is there which has been created into the linked list, uh, the address field of it contains null, which basically tries to tell us that there is no new node after this node, right? So when there is a null into the address field, it simply says it is now not pointing to anything else, which means I am the last node and I'm not pointing to anyone else. Because if it would be pointing to someone, then it would be storing the memory address of it. But because it is not storing any memory address, it simply says that I am the last node and there is nothing ahead than me, right? Okay. So we do have seen that basically how we create a node. We also have seen what is the use of function which we call it as malloc and size of, and how we allocate the memory to the node. We also have seen what happens when there are actually no nodes in the linked list, and what happens when we create the very first node, and how we make that node as the begin node, right? Also, we have seen that once a node is created, how it is possible to insert new nodes. And we have seen that there are two provisions for insertion. Either you can keep on inserting the new nodes into the beginning, or keep on inserting the new nodes at the end, right? And also we have seen that how deletion will happen, because it is going to be what we say, it is going to be a dynamic kind of data structure. So insertions and deletions can be very frequent, and they has to be performed in such a way that probably it frees up that area totally. So point is that deletion is also possible. And in case of deletion also, if we talk about singly linked list, so here first of all we have started our discussion with the very first type of linked list, which we call it as one-way linked list or singly linked list. So what is the main characteristic with respect to one-way linked list or singly linked list? It is that uh, uh, that uh, it has it has a next part, and the node of the singly linked list or the node of the one-way linked list has a next part, and next part is actually connected to the next node of the linked list into the memory. So this one-way linked list, why it is basically told as one-way linked list? Because you can always start from visiting the first node and you can go one way. One way means you can start with the first node or the begin node, and you can go till the end. And end will be nothing but a node which will be actually having null into its memory, into its next location or something like that. Okay. So that's where the one-way linked list is there. And again, if we talk about one-way linked list, okay, so it is going to have a data part and a next part, and then creation is possible, insertion is possible. So these new nodes can be inserted either into the beginning or the end of the linked list, and even deletion is possible. And deletion is also possible into the beginning or at the end of the linked list. Okay. So these are the operations which we have already seen, that how we can create, how we can insert, and how we can delete. One new operation that we are going to see, that we have already seen, if you remember, if we talk about arrays, then in arrays we have already seen about searching mechanism. So in arrays, when we saw about basically searching, then there were two different ways of searching that we saw in, if we talk about arrays. So in arrays, basically we saw that there can be something which is known as linear search which can be performed, and there is something which is also known as binary search can be performed. Okay. But now if we talk about linked list, okay, so in linked list, because the elements are not in a consecutive memory location, and yeah, of course, if the data in the linked list is sorted, but what will happen is that that even if you sort the data, if new nodes are going to come, you have to sort it again and again and again. So there, because of that reason, searching in the linked list is always preferred with respect to what we call it as in the linear fashion only. So today we are also going to see that how we can search an element into the linked list, and we are going to apply the linear search over here. Okay. Now when you talk about searching in a linked list, probably again you are talking about searching a data only. Okay, and that data will be residing in some node. So that's what we are going to see today, right? Okay. So let's start with the GUI for the node creation, right? Okay, so now how does a node look like? Okay, so what we have written is there is a node and only one node. Okay, now we can understand the first thing is that if there is only one node, then definitely it is nothing but our beginning node. Okay, and if it is only one node, which means it is not connecting to something else also, and if it is not connecting to something else, the next part of it is going to store null. So now we see a structure of a node over here. Okay, what you can see, and what we can see over here is that the data part is containing basically, let's say 10, and the address part is basically containing null, because this is the only one node. Also, this node is represented by begin, and when we have written 1000 over here, what does it basically means? The memory address of this node is nothing but 1000. So you can just understand that 1000 is somewhere over here, or the starting memory address of this node, and begin is just pointing this node, or actually begin is nothing but this node itself, and that's why it will contain the memory location of this node, that is 1000. So the memory location, or because this is just an example, okay, so we can just imagine, or we can just see that at some memory location 1000 into the memory, a node is created, and that node has two parts, the data part and the next part. In the data part, the value that is stored is 10. Okay, so we know that the first part is nothing but our data part. So in the data part, the value that is stored is 10, and in the next part, or in the address part, the value that is stored is null. Why? Because there is no other node into the memory. This is probably the very first time the linked list has started working, and that's why only one node is created right now into the memory. So this is a scenario, students, wherein we are having only one node into the memory. Now we all know that because linked list is something which is a dynamic data structure, and it is going to keep on expanding. So definitely we will not have linked list which is having only one node into the memory. Definitely there will be more nodes. Now if there are more nodes, okay, then we are actually going into a procedure of creating a new node first and then adding it, because this is not a sequential data structure wherein the memory location you have already booked into the beginning of the program, like arrays, and what you have to do is you have to just start giving the elements. No, it is not like that. So every time whenever you want to do an insertion operation in the linked list, your first task will be to create a new node first of all. And once that new node is created, you have to attach it to the nodes which are already existing into the linked list, right? So the very first process will be to just create one node and make that node as the beginning node. Once that is done, if now the requirement is there that you want to add one more node into the same linked list, in that case, the first of all situation will be you have to create one node. So, okay, fine, we created one new node into the, what we did is we created one new node, okay, into the memory. So now just focus on the first diagram. So we created a new node, and because the memory locations can be anything, it is 2000, okay, it is not sequential, please understand, it can be any random number. I have written 2000, but where 1000 is and where 2000 is, okay, they are spreaded across into the memory. There is a big difference between the memory address of this node and the memory address of this node, and it can be anything actually. The new node can be created at actually any memory location, right? Okay, so now in our example we have just discussed that the new node has been created at a memory location of 2000. What is the data value into the new node? 20. And as of now we have kept null into over here because we are not sure where exactly it is going to get connected, okay. But now, as we already have an information that in our list already one node was there, right? And a new node is created, which means somewhere we have to attach these two nodes, the first node and the second node that we just created right now. Fine. If you want to attach, you have two provisions. So whether you want to attach the new node into the beginning of the list or whether you want to attach the new node at the end of the list, okay. So we are seeing a scenario where we want to add a new node into the beginning, okay. Beginning means what? This was the node which was already there and it was acting as our beginning node, the node which was having value 10. But now we created a new node which is having value 20 and we want that it should now act as the beginning node. In that scenario, what will happen is that the begin node should now actually point to this node, the new node that we have created right now, okay. But how it can do so? How basically it can do so? So first of all, it has to get attached with the node which is already existing. So now which node is already existing? This node is existing, okay. And this node as of now is stored by the beginning node which is having value 1000. So now what if we write something like that new node of next, okay, when new node of next as of now it was null, but now the new node of next, or what we call it as temp of next, okay, is getting attached to begin, okay. And as of now begin is pointing to what? 1000, which means node 10 and null. So what we write is new node of next, let new node of next which was null, let it point to begin. Fine, okay, that is done, okay. So now new node of next is actually pointing to begin. Fine, okay, absolutely done, okay. So now what is happening? Instead of null, 1000 gets reflected over here, and because there is 1000 over here, definitely which node will come over here? A node which is located at a memory location of 1000. Fine. Now it was already having next part as null, so we keep it as it is right now because that is actually logically going to be acting as the last node now. Fine, this is the first thing we have to do. When we have to add a node into the beginning, we have to connect this node with the previous node which was acting as a beginning node. Fine, so that we have done. Is this the only task we have to do? No, we have to make one more thing. What one more thing? Now actually these node, the new node which we have created right now, should act as our beginning node. So now begin will point to this. Now when begin will point to this, we can understand what will be the memory location which begin will be storing now? 2000, right? Because what was the memory location of the new node? 2000, and now begin is pointing to the new node. So actually begin will be storing the memory location as 2000, okay. Let's get very clear with this scenario. So we have just first of all created only one node into the memory at that time that was acting as a beginning node, and the next part was null. Fine. We created one more node into the memory. Now again the next part of it was null, but now we want this node to get attached with the node which is already there into the memory. So what we did is whatever the next part of this new node was there, we connected it to the beginning node, and then we made this node as our beginning node. So now what is our linked list looking like? So now our linked list, which initially was having only one node, now is basically having two nodes, the first node is having the data value as 20 and the second node is having the data value as 10, and the first node is pointing to the second node. How it is pointing? Because the next part of the first node stores the memory address of the second node, and now the first node is also known as the begin node. Fine, clear till here, right? Now the requirement grows. The requirement says we want to create one more node. Okay, if you want to create one more node, the first procedure of creating a node remains the same, because whenever we are creating a node, we are allocating memory. So students, that part is going to remain the same. Okay, creation of node will happen independently, and once that node is created, it has to just get attached either into the beginning or into the end, whatever is your requirement. Okay, fine. So what we did is, now we created one new node into the memory. We created it with the data value of 30, and of course the address part is null, because as of now it does not have any connection. It does not know how to connect. Okay, so that is independently created, and let's say it is created at a memory location of 30,000. Fine, okay, that is done. But now what we want to add again this node into the beginning. Okay, if you want to add this node into the beginning, first of all we should know what is our beginning node. As of now our begin node is 20, and at which memory location it is? 2000. Okay, so what we first did is that the new node that we created right now, the next part of it, which was actually having null, but now it should be connected somewhere. So where it will be connected? 2000, which means what? The previous beginning, because previously beginning was pointing to 2000, because it is pointing to 20. So we kept 20 over here and 2000 over here, and as soon as we kept 2000 over here, now the new node that we have created right now is pointing to 20, and 20 was already pointing to 10. That part was done. So this is done. So now the linkages are done. The new node which is created, it has actually pointed to the next two nodes. How? It has started pointing to the next node, which was previously acting as our beginning node, and then the other rest of the connections were already been done. So this is done. Now what one more thing we need? We have to make this new node as our beginning node. Okay, so now begin will point to this node, and when begin will point to this node, what will be the memory location of begin? 3000, right? Because what is the memory location of node over 30? 3000. So now it is 3000. Now just understand a scenario. If you want to create one more node, okay, so definitely first of all that node will be independently created into the memory. It will have a memory address. In the next part, as of now it will store null, and then what will happen is that it will first of all get connected to the begin node which is already there, and then that part will become as a beginning node. So this is how students basically what we call is that new nodes are created and how they can be added into the beginning. So this is a scenario if you want to insert your nodes into the beginning, right? Now there can be another scenario when you want to insert your nodes at the end. Okay, so what we understand the situation from the second node, right? So even if you want to add it at the end, of course there will be one node which will be already existing into the memory. So think about this scenario again, where there is only one node into the memory which is having value 10 and null. Now here what we have seen, we create a new node and add into the beginning. Instead we are seeing a scenario wherein we create a new node, so that part will remain the same. We have to create a new node, we have to give it data value, and then we have to we will as of now make the next part of it as null, because we have not yet decided its linkages. So that first part will definitely be done. But now what is the requirement? The requirement is to add in AND, or what we call it as insert in AND. So if you want to insert in AND, basically what you have to do is you have to actually go till the null. Okay, so you have to see your first linked list and go till the null. So initially what was happening, that this node, the first node that we created was actually having null. But now we want one more node to be added after it. So it is very simple. What we are going to do is, okay, now because it is only one node, students, you will see that we can just write begin of next and then attach the new node to it. But what if more nodes are then into the memory? So let's say there are 5 nodes into the memory. In that case, the 5th node will be having your null. So what is the first process is that you have to first of all find the last node of your memory. Now, if there is only one node created into the memory, the first node and the last node is the same. So what we will do is that simply whenever we go to a node which is actually having the null into it, okay, and we find that node into the linked list, we will attach the next part of it to the new node that we have created right now. So now what is the new node that we have created? 2000. So initially 10 was having null into its memory location or into its next part, but now it is having 2000, which means it is pointing to a node, and definitely 20 will point to null because it has nothing to point again. Now if we see our linked list, then basically it contains two nodes. Okay, so if we now want to add one more node at the end, basically first of all we have to start with the beginning node, because we only know what is the beginning node, and then from the beginning node we have to go towards the end node. So what we will do is we'll start from the beginning node, we'll check whether its next is having null or not. No, it is not having null. Okay, so what we do is, because we have to traverse the linked list and we should not lose our beginning node also, we create a temporary node, and temporary node also starts pointing to the beginning node. So just imagine a situation wherein there is also a temp which is pointing to this. Okay, now it will just check whether the next of it is having null. No, it is not having null, which means this is not the last node. And then it will go to temp of next. Temp of next means it will go to a node which is located at memory address 2000. Fine, it will go over here. Whether it is having null, yes, it is having null, which means it is the last node in the memory. So now just think of the next situation. We create one more node and we want to add it at the end. What is the scenario of our linked list, student? We are having 10 which is pointing to 20, and 10 is storing a memory location 2000 because it is pointing to 20, and 20 is storing null because probably it is not pointing to anything. But now we want to create one more node and add it into the end. Add it into the end, which means now initially what was our last node? 20 with null. Basically this scenario will not remain the same. Whichever new node is there will has to be attached over here, and then that new node in the next part will have null. So we created a new node, that is 30, and then what we saw is that, let's say 10 for 10 is being attached to 20, then 20 was actually having null, but now it is now pointing to the new node that we have created just now. And what is the memory location of the new node? 3000. So in 3000 is what we see reflected over here, and then it gets connected to the node which is having the value 30. So that's how now the nodes are getting added into the end. Now, whenever you want to add a node into the end, you have to make an extra effort to go at the end of the linked list and then do the addition. Whereas if you want to add a node into the beginning of the linked list, there is no extra effort because there is a begin node which is already there, and just a simple change into the links will help you to do so. But over here, to find out which is the last node into the memory, because if you want to add into the end, you have to first know the last node. So now students, if we see this linked list, and if our requirement comes that go add one new node into the end. So if you want to add a new node into the end, our traversal will start from here, and we will check whether this is the last node. No, of course we will create a new node first of all over here, then we have to add it. So where we will add, whether we will add it over here? No, because it is not the last node. So let's go ahead, whether we will add it over here? No, because it is not the last node. Then we will go over here, whether we will add? Yes, we can add over here because now it is the last node. Okay, so that extra effort needs to be done whenever a traversal is there at the end of the at the end, or whenever there is some operation which has to perform at the end, because it is a one-way linked list. So we are aware about what is the beginning part, but we are not aware about what is the end part. We have to go to a node which is having null, and thereby we can understand, yes, this is our last node. Okay, so that is about a representation, how we create and add into the end. Okay, now there will be a representation of how we can perform the deletion operation. So of course it is very clear that if you want to perform a deletion operation, a linked list should actually be there. If it is there, then only deletion is performed. But now again you have a provision whether you want to delete at the beginning or delete at the end. Okay, so let's see. So now we are talking about a scenario where we want to actually delete into the beginning. So what is our current linked list looking like? Okay, our current linked list is looking something like this. First node is actually storing the value 10. It is pointing to the second node, and the second node is pointing to the third node. And we have seen when you write 2000 over here, 2000 is nothing but the memory location of the second node. And when we have written 3000 over here, 3000 is nothing but the memory location of the third node. And third node is not actually pointing to anyone because the linked list is getting terminating over here right now. So that's why it is having null. Fine. This scenario is clear. Now a request come from the users, delete a node which is there into the beginning. Fine. Okay. You have to delete a node. So as such, it becomes very easy that whichever node of the begin pointer was pointing, just delete them. But now if you just simply delete the node, then how we will come to know that now after what, which is the beginning node? Because if you're deleting a beginning node, then the next node should become your beginning node, right? Okay, it should not be that the position of the beginning should be lost itself. That if something is getting, and that is what the dynamic behavior is. If something is actually deleted, then the next who was attached to it should actually now start behaving as the beginning part. So what we have seen in algorithm, students, was that if I want to delete the beginning node, first of all what I have to do is that whatever node is being pointed by this beginning node, so I can say what is this 2000? This 2000 is begin of next, right? What is begin of next? Begin of next is nothing but these node. So what if I make my begin node as begin of next? Okay, so what is begin of next? 2000. 2000 is pointed by which node? The node which is having the value as 20. So now first of all what I do is I remove the begin from I what I do is that I actually get the value of what is begin of next. Okay, and I try to point it. Okay, I try to get it. I try to get these node. I store it somewhere. Okay, so you can take a temp variable and store the information of these node. Then you say you want to delete this node, you delete it, and then whatever information of these nodes. So basically you're trying to tell is you don't want to lose the value 2000, because once you will delete this node, this value will also be lost and you will not be able to know that these node is pointed by whom. So what I will do is I will simply write something like temp equals to begin of next. Now what is begin of next? 2000. So the value 2000 will come in temp. Then I will say delete begin. Let the begin get deleted. Okay, that is deleted. And then now what I will do is what was stored into the temp 2000. So I will say begin equals to temp. So which means the node which is having the memory address as 2000 will become our beginning node. And that's what we see over here, students, right? So first of all, point over here is that you have to preserve this value before you delete that node, because if you delete that node, you will not be able to understand to which node it is connected. So I will store this value 2000 somewhere, and then I will delete this node, and then I will make the node which is pointed by 2000 as my beginning node. And which node is pointed by 2000? So we know that the node which is having value 20 is pointed by 2000, and that will now be our beginning node. Okay, now so if you want to understand the situation in a more continuation, so what you will see is, now you will again say you want to delete in beginning. Let's understand this word. So what you are going to do is you will not first delete this node. Instead, you will store the value of 3000 somewhere and then delete this node. And then what you will do is you will make your begin value as 3000. And what is 3000? 3000 is nothing but your these node. So now your begin is going to point to this node, right? Okay. And probably when you have nothing to store, and even this node will be deleted, you can simply say that now there are no nodes available into the linked list. So it is a possible, it is going to be there if you keep on deleting each and every node which are there into your linked list. Okay, so this was about deleting in beginning. If you want to delete in begin, you have to just preserve the information about the node which is after your beginning node, because your begin node is going to get deleted. So you should know now which node next is going to act my beginning node. Okay, so fine, this is still simple. Now what if you want to delete at the end? Okay, so if you want to delete at the end, first of all you should know which node is in my end. And if you want to know which node is into your end, again you have to do a traversal procedure. So fine, what you do is you start with the linked list, you start with begin, you will see whether my next is equals to null, no, then you go to the next, then you will see whether my next is equals to null, no, then you go to ahead and then you check whether my next equals to null, yes, so which means this is my last node. Okay, and then you decide to delete it. But before you want to delete it, let's say if you simply delete this node and this is again pointing to 3000, but you have actually deleted what was there at 3000, so which means you have to tell to the previous node that now the next node which was attached to you is deleted. So when you keep on traversing, and if you talk about singly linked list, you have to keep on checking the next condition previously, right? So over here only, when you come to this node, over here you have to, so at every node you have to check two conditions, that whatever my next node is, whether it is containing null. So when you come at 20 is actually having 3000, so you visit 3000, so there will be temp and temp1 going parallelly, right? Temp1 will be actually pointing here and temp will actually be pointing over here. Okay, and temp will tell you that yeah, the next of it is null. Okay, so which means while you are at 20 you come to know that 30 is having null, right? And this you should be aware of. Once you know that, what you do is, because it is now having the value of temp and this is temp1, you will say temp1 of next let point to temp, let that connection be done. Okay, fine. Oh, sorry, that connection is already done. Now because we are deleting, our point over here is that this is temp1 and this is temp, and we came to know that temp is actually a node which is going to end our linked list. So what we do is that we make our temp1 of next as null. When we can make our temp1 as null, when it tells you a situation that each temp of next is actually going to nothing but store null. Okay, so that's what we have seen. If you remember into the algorithm also, we have iterated about temp till null, but simultaneously we have also maintained the value of temp1. Okay, so initially what will happen is temp and temp1 will be over here, but then what we do is we move our temp one step ahead. We say temp should become temp of next and then check the condition. So every time we do have an information, because it is a singly linked list, it becomes very difficult how we can have information about our previous node, because if you go ahead you will lose the information of that node. So that's why we preserve two pointers over here. Okay, one pointer which will go ahead and one pointer which will stay there and move one step. We can say, it will move one step less than one another pointer, and that's how it happens that you do an operation of what we call it as deleting into the end. Okay, so yeah, this is about insertion and deletion, and the respective algorithms we have already seen, and now also we have seen that how diagrammatically these things happen. Fine. Okay, now let's think about a situation where we want to actually perform a searching operation into our linked list. Okay, so now if you want to perform a searching, so definitely the searching will happen with respect to the data, and it will not happen with respect to memory location. Okay, but you have to go to a particular node, which means you have to go to a particular memory location. Then only actually you will come to know whether you have got your data or not. Okay, so how the searching algorithm will start? Of course, the step one will be take input of the element to be searched. First of all, we will ask from the user which value from the linked list you want to search. So let's say we give a message printf, enter the search element, scanf %d, enter the search value. Okay, and percent search value. So let's say we receive a value. Fine. Now we have to begin our traversal, because we have to visit all the nodes and we have to check whether this search value is present into the data part or not. So we have to start with the traversal, and because we have understood that when we have seen about searching, we always prefer to have a flag status. So if we found the search, then we want to exit, and thereby we set a flag status just telling that we have found our search, and if we have not found our search, vice versa. So let's say we have taken a variable which is known as flag, we have set it to 0. There are two nodes which are available with us, that is temp and begin, and we initialized our temp node with the beginning node, which means now temp is also pointing to begin node. Okay, now what is our next step? Okay, because temp has already started pointing to the begin node, which means temp is at the same place where the begin is there, and now Of course, begin has to stay there it is, because if it will move, then the position of the begin will be lost. So begin will stay as it is, but because now temp is also pointing to begin, temp can start iterating. Okay. So what we have done is, like, while temp is not equals to null, okay, which means whether the value of temp we have not got equals to null, if temp of data, which means the data value which that node is having equals to the search value which the user has given us, flag equals to 1, which means if the node that temp is pointing, if the data of it is equals to the search value which the user has given, which means we have found the search, then we will make flag equals to 1 and we will break. Why we will break? Because there is no point in moving ahead, we have got the search value. Okay. Now one part over here that is missing is that after, so let's say if this is not the case, okay, if it has not got the search value, basically in that case it should have temp equals to temp of next. Okay, so it should start moving ahead. Fine. Now what we'll be having into the else part is else temp equals to temp of next. So what basically will happen is that so if condition will iterate, first of all it will check the data value whether it is equals to the search value. If it is there, it will make flag 1 and then break. It will not iterate. But let's say it is not equals to the search value, which means it has to go to the next node, right? And to go to the next node, it has to write something like temp equals to temp of next. So after this if, there will be an else condition, and in that else condition one line will be written, that is temp equals to temp of next. So what will happen is that temp was first at the beginning node. It will check the data whether it is equals to the search value. No, it is not equals to the search value. Let it go to the next node. Let it go to the next node, and wherever, let's say, it finds the data value to be the search value, it will make flag equals to 1 and it will break from there. Okay. Once it is done, we'll check the status of our flag. So if flag equals to 1, when flag will be equals to 1, when we have got our search value into our linked list, in that case we will print search value found in the linked list, else we will say search value is not found. Okay, it's as simple as that. So now we take an example. So this is our linked list, and let's say there are nodes. There are 4 nodes. Okay, so a node like 10 is connected to 20. So of course this is a representation, but basically 10 will also have a memory address, and that memory address will be pointing to 20. So that's why we have shown just arrow over here. So let's say the first node, or we can say the begin node, is 10. It is pointing to 20, 20 is pointing to 30, 30 is pointing to 40, and 40 is not pointing to anything, so that's why it is null. So basically 40 is our last node. Let's say the search value that is given by the user is 20. Okay, so what will happen? Our search will start over here, because this is our beginning node. It will now also act as our temp node. We will see what is the data value of temp. Is it 20? No. Then go to temp of next. What is temp of next? This node. What is the data value of it? 20. Okay, we found the search. We can exit over here. Let's say the search value could be 40. In that case, what will happen? It will check the data value. No, it is not found. It will go to temp of next. It will check the data value. Is it found? No. It will go to temp of next. Is it found the data value? No. Go to temp of next. Is it found the data value? Yes, it will receive the output. Now a scenario could be that the search value does not exist. Okay, in that case, again it will do the same procedure. It will start with the first node. It will check its data value. Is it equals to the search value? No. It will go to temp of next. Is it equals to search value? No. It will go ahead. Is it equals to search value? No. It will go ahead. Is it equals to search value? No. It will go ahead, but there is nothing ahead because this is the last node. And if it scans, or if it searches the whole linked list and it does not found anything, it has reached a terminating condition where actually now temp has found null. It will just go out of it, and because the flag status will not have been changed, flag will not have been become 1, because we didn't found that value, it will simply say that search is not found. Okay, so yeah students, this will happen if we look into the searching mechanism. Okay, let's just again quickly see our algorithm. Okay, so there is one change into the else condition that I'll again tell you. Our step 1 should be to take the search value from the user. Step 2 should be making our traversal. To do that, we have to make a temporary node. We have to create a temporary node, and we have to assign it the same value which our begin node is having. and also we need to have a flag variable whose value is equals to 0. We start with the traversal, and because we have to go to the end of the linked list, because we have to search the entire linked list, we have put a condition that the traversal should happen until and unless temp does not get a null value, which means as soon as temp is having null, we should actually exit from our search, right? Okay, because there is nothing to search, we have reached null and there is nothing to search ahead. So that is one thing. Now, whenever we come across the nodes, which means temp will be pointing to the beginning node, then afterwards it will be pointing to the next node, then next node, then next node. Every time we will check its data value with the search value which the user has given to us. If they match, we will set flag equals to 1 and we will break from there. We will not search ahead now because we have got our search value. Else we have to go ahead. So students, again I'm telling you, after this if there will be an else condition, and in that else condition there will be one line written, that is temp equals to temp of next. We are telling temp that now because you have searched this node, please go to my next node. Okay, fine. So these will keep on happening. Temp will go on going to next and next until actually it reaches null, or either it gets the search value. In any of these conditions it will stop, else it will keep on going ahead. Fine. After that, in any of the situation, this loop will break. Either the linked list is over, or it will break, or either the search value is found in any of the conditions. So once we come out of the loop, we check the value of the flag, whether it has become 1. If it has not become 1, if it has become 1, we will simply say your search value is found. And if it has not become 1, we will say the search value is not found. Okay. And this is the example wherein we are having, let's say, 4 nodes, each of the nodes having data value as 10, 20, 30, 40. Given a scenario where we give the input, or we can say the search value as 20, we will get the output as the search found, because what will happen, this condition will become true, and once this condition will become true, flag will become 1 and it will break, and if flag will become 1, it will say the search value is found. Given another scenario wherein we have the same situation but we give the search value as 50, what will happen is that it will not be able to find, and the whole loop will get completed, and the status of flag will not have been changed, and that's why we will say that the search is not found. Okay, so yes students, okay, so this is how we understood that how we actually create nodes, and afterward creation of nodes, how we actually perform their insertions into the either beginning or the end of the linked list, and same way how when a linked list is already existing, how we can delete a node into the beginning as well as into the end, and how we can perform our searching operation. Okay, so yes students, that was there for today. Thank you all of you. Thank you.